Hi, hello friends. Welcome to my YouTube channel. Thank you for your views and comments. It really motivates us to do more and more for you. Thank you. Now, I would like to discuss the Tancet paper. So, our Tamil Nadu friends is going to write exam on this Sunday, right? So, for them, it will be useful. So, now I am discussing the Tancet Electrical Engineering and Instrumentation and Electronics and Communication Engineering paper of 2011. The first question, as you can see here in the figure, the value of r. We need to find the value of r here. So before going to find the value of r, so we need to apply some KVL here. So while applying KVL, it's an algebraic sum of voltages in the loop. So algebraic means plus and minus should be given. Okay. So we now to make that notation, I will give plus here and give minus here. Why? Because current entering in a passive element at positive terminal only. Now here, so these two resistances are in parallel. So what will be its equivalent resistance? So R1 R2 by R1 plus R2. So 10 into 10 divided by 10 plus 10. How much it is? It is going to be 5 ohms here. So I will write plus minus equivalent 5 ohms here. Now we can apply the KVL inside the loop. So by KVL, what you can write is minus 100 plus 8 into R plus 5 into 8 is equal to 0. So from this, R is equal to 60 by 8, which is nothing but 7.5 ohms for this. So 7.5 ohms is the answer for this question. So option 3 is the right option for this question. The next question here, the RMS value of a voltage U of t is equal to 3 plus 4 cos 3t. And what we need to find here is RMS voltage here. But don't think about this circuit diagram. It is just given to make you confusion, right? So U of t, we need to find RMS value. So U of t RMS is equal to, so square root of average voltage square plus, so here one concept is that VRMS is equal to Vm by root 2. So it's a maximum value here. So maximum value means 4 divided by root 2. I'll take whole square here. So is equal to square root of 3 square means 9 plus 16 by 2. So it's nothing but square root of 17 volts is the answer for this question, right? So square root of 17 is the right answer. So we'll move to next question. Next question here. In the figure, the initial capacitor voltage is 0. So this capacitor voltage is 0. The switch is closed at t is equal to 0. Okay. The final steady state voltage. So during steady state, so final steady state, or so in final steady state, capacitor act as a open circuit, and it will be charged up to a voltage across this 10 ohm resistance. So capacitor is charged up to how much? 10 ohm resistance voltage here, so which is here. Okay, now I will draw the equivalent circuit during steady state of this network, right? So we will take steady state here. So how much voltage? It is 20. Now it is at 10, and capacitor is open circuited, so I will not draw that capacitor here. So 10 ohms here. Here are the 10 ohms. Now I need to find the voltage across this because here the capacitor is present. So we'll take VC. Okay, so VC will take VC of infinity during steady state. Now the voltage across here 10 ohm resistance you can find by using voltage division rule. So by using voltage division rule, so VC of infinity is equal to total voltage Vs into resistance at the output divided by total resistance 10, and this will be 10. So total how much? 10 plus 10, 20. So it will be equal to 10 volts here. So answer for this question is 10 volts here. Okay, we'll move to the next question. Next question here. A system with zero initial conditions has a closed loop transfer function T of s is equal to s square plus 4 divided by s plus 1 into s plus 4. The system output is 0 at a frequency. So this system is there. So system output is 0. System output means this is the transfer function, output should be 0. So they did not mention initial values, so 0 values. Okay, so T of s is equal to s square plus 4 divided by s plus 1 into s plus 4. Now here we'll substitute, we need to find the frequency, so put s is equal to j omega. So T of j omega is equal to j omega whole square plus 4 divided by j omega plus 1 into j omega plus 4. So which is equal to 0. Now, so from these solutions, what I can say is j omega whole square plus 4 is equal to 0, because this denominator part is going to be equal to 0. So we'll have only this part. So j square, j omega square plus 4. So j square means already we know minus 1. So directly I am writing minus omega square plus 4 is equal to 0. That implies, so omega equal to 2 radians per second is the answer. So answer here is 3 is the right option for this question. Next question. Next question. A three-phase diode bridge rectifier is fed from 400 volts RMS 50 Hz three-phase AC source. If the load is purely resistive, the peak instantaneous output voltage equal to. So the peak instantaneous or maximum voltage is equal to, so root 2 times that of V RMS here. So we know the formula, V RMS is equal to Vm by root 2. So Vm is equal to root 2 into Vrms. That formula we are going to apply here. Root 2 into 400 volts RMS. So answer will be 400 into root 2. So units are volts. So answer will be 2 here. Okay. So we'll move to the next question. The next question here. The figure shows the root locus plot. The location of the poles are not given of a third order system whose open loop transfer function is. So to find this open loop transfer function, let's choose this first option. Okay, so where the characteristic equation of this option is 1 plus g of s h of s is equal to 0. So what is this transfer function taking? K by s cube, no? So 1 plus k by s cube is equal to 0. Okay, so from this, what is the breakaway point? So breakaway point dk by, so ds if you found is equal to 0, that implies you will get it as 3s square is equal to 0. S is the points, we have two origins here. Okay, so the points are moving from this here like this. So most appropriate answer will be this one, or because others are not satisfying this condition. Okay, next question. Next question here. A unity feedback system has an open loop gain of g of s h of s is equal to k into 1 minus s divided by 1 plus s. Becomes stable when. So we need to find the stability when the what is the value of gain k here. So to find this, we'll follow the RHS table column. So for which we require characteristic equation. The characteristic equation is 1 plus g h of s is equal to 0. Okay, so based on this, 1 plus k into 1 minus s divided by 1 plus s is equal to 0. That implies what will get 1 plus s plus k into 1 minus s is equal to 0. So by simplifying this circuit, we can write as s into 1 minus k plus k plus 1 is equal to 0. So if you form the table column of RH criteria, so s power 1 is there and s power 0 is here, right? So 1 minus k, and here it is k plus 1, that's it. Okay, this column. So among them here, so 1 minus k should be positive value. So 1 minus k should be greater than 0. That means 1 should be greater than k, or k should be less than 1. So among the option, k is less than 1 is the right option for this question. So next question is also from control system. When subjected to a unit step input, the closed loop control system shown in figure will have a steady state error of. So we need to find the steady state error. So it is simple. Now here we have a component called integrator, so which will give the integration of the signal. So integration constant 3 divided by s. The inputs which are coming here are of s, y of s. So it's a difference. So r of s minus y of s. Now here for this signal, so this signal again added together. So what is the total signal here? It is nothing but 3 by s into r of s minus y of s. Again here is again here it is minus of r of s. Okay, so this is a signal, and it is multiplied by this transfer function of 2 by s plus 2. So overall transfer function I'm going to write here. So here are this. So y of s is equal to, so 2 divided by, so this block I'm writing s plus 2 into, so 3 by s into r of s minus y of s minus again r of s. Okay, so by simplifying this network, I will write in terms of y of s divided by r of s, which is nothing but 6 minus 2s divided by s square plus 2s plus 6. Okay, now from this we need to find the error signal. So error signal is nothing but e of s is equal to r of s minus y of s. So which can be written as like this. So what is the r of s? Already you know, y of s you know, right? So we make a difference here. So by simplifying this network, we can get r of s into s square plus 4s divided by s square plus 2s plus 6. Okay, now we need to find the error. Steady state error ess is equal to limit s tends to 0 s into e of s. Okay, so by substituting here limit s tends to 0, so s the input what we are using is unit step, so r of s becomes 1 by s here into this value s square plus 4s divided by s square plus 2s plus 6. So if we substitute s is equal to 0 here, everything will go 0 by 6 will come, is nothing but 0. So steady state error for this network is 0 only. About next question. Again, next question from control systems itself. In the GHS of plane, the Nyquist plot of a open loop transfer function g of s h of s is equal to pi into e power minus 0.25 into a divided by s passes through the negative real axis at the point. So similar kind of question is asked in GATE 2019. Okay, we'll take the transfer function here. So g of s h of s is equal to pi into e power minus 0.25 into s divided by a divided by s. So here we'll take a formula here, e power minus a into s can be written as, so cos a omega minus j sin a omega divided by j omega here. So I'm going to use this formula here, note it down, it's a very important formula. Now, so we'll take the transfer function. So g of s h of s, so g of s h of s is equal to, so pi into, so pi, so instead of writing this e power minus 0.25a, I can write this, substitute this formula here. So where I get cos, instead of a I will get it 0.25 omega minus j sine 0.25 omega divided by, So we get j omega. So if you substitute the j omega, if we go on top of it, so what you will get is it's going to reverse here. So j omega gets cancelled here. I will write this one minus. So I'm taking this first term here. So minus sine 0.25 omega divided by omega, and this is going to be minus again here. So minus pi by omega into j into cos 0.25 omega. Okay, so now imaginary part should be made equal to 0. Imaginary part is made equal to 0. So to find the transfer function passes through a negative real axis or not. Okay, at what point it is going to touch it. So negative imaginary part 0. So this point is going to be 0. That means I will write minus pi by omega into cos 0.25 omega is equal to 0. So from this point of view, so 0.25 omega is equal to 0 when it's going to be 90 degrees. So pi by 2. So from this, omega equal to 2 pi here. So from this, okay. Now we'll substitute the point. So magnitude of g h of j omega at omega equal to 2 pi is equal to, okay, so we'll take real part only. So minus sine 0.25 into omega value is 2 pi divided by 2 pi, and so which is equal to minus 0.5 is the answer for this question. So let me correct here. Here we have, here I forgot about the pi, and here also we have a pi. Okay, so the answer is minus 0.5 comma j0. So this is the answer, correct answer for this question. So make it correction here. Here it is a pi is there. Next question. Next question. The equivalent circuit of a transformer has some leakage reactances x1 comma x2 dash and magnetizing reactance xm. Their magnitudes satisfy the condition of x1 is equal to x2 dash and they are much less than xm value. So this is the condition here. Okay, next question. Again the question is from transformers topic. Which three-phase connection can be used in a transformer to introduce a phase difference of 30 degrees between its output and corresponding input line voltages? So star to star will give a phase displacement of 0 degrees, and delta will give a displacement of 0 degrees, and here, so delta zigzag, it also gives a degrees of displacement of 0 degrees here. So the right option here it will give a displacement of 30 degrees. Okay, so only 30 degrees is possible with the help of star to delta connections. Okay, next question. The next question here it is from induction machines. For an induction motor, the operating at a slip S, the ratio of gross mechanical output to the air gap power equal to. So there is one important formula. You should remember this formula here. The power air gap is to power copper losses is to power gross mechanical is equal to 1 is to S is to 1 minus S. So based on this, the ratio of gross mechanical output to the air gap power PAG is equal to 1 minus S by 1. It is nothing but 1 minus S. As the answer it is 2. Okay, thank you friends. So that's it for this session. We'll continue this remaining questions in the next upcoming sessions. Thank you friends. Thanks for watching my video. If you like my video, please subscribe and share and comment. Thank you.